Good morning, everybody. Here's KJ4YZI, Saturday morning, and I'm trying to make a video here to answer some questions and thank everybody that congratulated me. But more importantly, I got a lot of people that wanted to finally take the plunge and try this EME Moonbounce, and I guess that was the only purpose of my video, was to show that you can do this. It's different for everybody, and I want to just throw out some things in a video. I don't know how long this video will be, not too long hopefully, to show you some of the things that I have learned, and this has been the biggest addiction in this hobby that I've ever had. So I figured let me throw some ideas out. If those are wanting to try it and you want to get into something like this, it's a little tough. It's not successful all the time, but it is the ultimate achievement for ham radio. And I figure I could pass my knowledge on to show you and get you guys started, because hey, we need more people doing this. Let me start with the antenna. Now I'm going to recap this one more time, but I don't want you to focus on this antenna because this antenna is no longer made. And I would have chose a different antenna had I had known a lot more 8 years ago. This antenna was in a box for 8 years. You know, and this is the high gain UB7030 SAT. If you wanted to look up the manual and just look about it, this is a circular polarized Yagi for Oscar satellites, and it was originally designed where you have the 2-meter version over here, and you could switch between, you know, uplink and downlink, or have your uplink and downlink, and switch between right and left hand circular polarization. Now, I did some videos and struggled with the antenna in the beginning, but the antenna is working now, as you saw in that video where I did one EME Earth Moonbounce to Frank NC1I in Massachusetts. And I was actually facing over there with the moon the other night, like 11:40 at night, okay? So I don't want you to say you have to go run out and find this antenna, because this isn't the optimal antenna for this, but it did work. What you would want optimally, from what I see and hear and talking about everybody online, is a linear antenna, because the circular polarization, from my understanding, you're losing 3 dB on transmit and 3 dB on receive for the circular polarization. That's what people told me. A lot of the guys that are on the big guns on the other side, they don't have circular polarized antennas. They have stacked Yagi linear arrays, okay? So if I had it my way, I would do away. I'm not still convinced that the circular is working, but if I had my way, I'm going to take this apart, take this out, and redesign this as a linear antenna with the option of me being able to rotate the boom and rotate it horizontal and vertical. Seems to me that a lot of people are transmitting horizontal polarization. And now here's how this works. When you transmit horizontal, let's say horizontal here from Vero Beach, Florida, and it hits the moon and comes back, the receiving station on the other end is going to be receiving you vertical. The polarization changes, as well as the circular polarization antennas. If you transmit right hand, they should be listening left hand, vice versa. Sometimes it works right hand to right hand. Sometimes it works horizontal to horizontal. The moon surface is not smooth. So 1 degree on Earth, like this, right? Not even 1 degree could mean the difference of reflecting off the surface of the moon in a huge crater, or off the side of it, which is going to send your signal back. It's just a big reflector. That's what it is. And of all the signal being pumped to there, you know, it's an uneven surface, it's rough. Only about 7%, I think I read, is reflected off of the moon. It's not reflecting everything you're sending at it. That is why you need to have a big gun, what they call a big gun, on the other side. A big gun is somebody like HB9Q or other ones that have, in Europe, that have like 48 stacked Yagis on this array, that the entire array can be rotated this way, elevation, azimuth, rotated horizontal, vertical, circular polarization this way, that way, and more, with like 1,000 watts. Okay, that would be a big gun, and that's what would be hearing me on the other side. Although I don't think Frank NC1I is a big gun. I think he's got 2 9-element Yagis. I think I have to look up and see what I talked to. Okay, so don't focus on you have to have this antenna. A lot of people said they wanted to get started on this. I pushed them over the edge, and that was the ultimate goal of this video, is to show you can do this and other people can do it as well. Because I still have comments coming in that haven't seen the video the other night, and people are telling me it's never going to work, and they're like, you know, it's a good, you're going to have fun experimenting, but it'll never work. Well, they haven't even seen this video. I just dropped the link in there and hope they see it. It did work. Was it optimal? Probably not, but I did it. One more thing. I'm doing this, before we move on, I'm doing this Armstrong method. You notice my little thing broke off here? I'm having a little trouble with understanding. I must be throwing something off with the calculation of the height above ground. All I do is this. I look down at the moon, right? And I get my elements lined up right on the moon like that, okay? And every couple minutes, you might have to tweak it a tad bit. That's how I did it over here on the right side of the yard. If you wanted to have an azimuth elevation rotor, that's fine. What I can't figure out is, when I said I had a protractor, a little thing hanging, when it was like this, let me see, when it was like that, you know, hanging about 30 degrees, guess what? The moon was way over here. I got to be calculating something wrong. So in my continued practice here, I'm going to be doing this by hand, because when I can see the moon, I can get it on the moon like this, and I could decode signals on the digital mode. And I'm going to tell you about that digital mode here shortly, and along with the scheduled chat site that I use. Okay, so for professionals, they don't have to go outside and do it this way. But if you have a comment on that, please, because I do know that if 30 degrees here, if I were to raise or lower that, it's going to change the 30 degrees of where it's pointing. So I must have to figure that out. I must have something wrong where when it said 18 degrees, I had it at 18 degrees and the moon was over here and I was pointing over here. So something's definitely wrong. If there's clouds like this, I could not do it because I'm using this method like this. That's to me, very archaic and more rewarding that I did it myself with my hand. But for some people, they don't want to play around. We know that. Okay, so don't focus on just this antenna. M Squared makes antennas. Let me tell you about the specs real quick on this antenna. This is a 134-inch boom, 30 elements. That's 15 horizontal, 15 vertical, and covers 432 to 438, 14.0 dBdc, which I understand is 14 dB relative to a circular dipole, I think. Because dBi would be decibels related to a isotropic radiator, okay? So 14 dBd of gain, 28-30 degrees beam width. Front to back ratio is 25 dB, okay? Handles 200 watts. So that is about what I'm using. So if you look at some antennas online, you may want to look for something at least that comparable, maybe a little less, a little more, okay? And I would do linear, because like I said, linear, you're going to lose 3D. Circular, you lose a little bit. A lot of the guys are linear already, which is just a regular horizontal dipole or horizontal YAG, okay? Now, the feed line. So the feed line is very critical. However, for this little distance right here, I don't think it's as critical as I'm making it out to be. I mean, what I mean is, as early as it is in the morning, I'm using Andrews. There's got to be a number on here. I have a bunch of this stuff too. All right, it's not on this one, but it's Andrews. Might be over here on this piece. Here it is. Let's see if I can get this. This is FSJ450B. This is Andrew's 7/8 inch Heliax hardline. See, and you could take this and you bend it, it stays bent, right? That's pretty solid. I mean, those connectors are expensive. That's expensive, but the loss of that stuff at like 300 feet going up a tower, it's very minimal compared to something like RG8, which you would want something better. I think they recommend at least LMR 400. That's assuming that your antenna is outside on a roof or on a tower and you're 50 feet in the shack, okay? Every dB counts. 3 dB is a big deal when it comes to Moonbounce. I mean, there's a calculation on the dB loss of you to the moon, the dB loss of the other station to the moon, the dB loss of what's lost on the moon, the dB loss between the two stations, depending on antenna orientations. Comes out to like 250 something dB of loss, total. And you have to combat that with software, digital mode that will decode, 28 dB below the noise floor and stuff. So every dB counts. However, in my situation, I don't think that stuff's heavy. When you put that stuff on, man, this antenna gets weighed down. So I do have some leftover Messy and Poloni. This is Hyperflex. Where is the code on this? Nothing's got codes anymore. Here it is. This is Messy and Poloni, made in Italy, Hyperflex 10. And that's got a pretty good low loss characteristic on this. I'm probably going to crimp a couple, put some end connectors on that, as it'll be a lot lighter, okay? End connectors are lower, well, apparently, end connectors are lower loss than PL259s. That's why everything with UHF has end connectors. You ever notice that? Back of your 9700, this antenna, the back of my amplifier, which I had to use an adapter here because these are N and I didn't have, my 705 has a SO239 on that W2HVH case. So long story short, good coax, good feed line. For this short a distance, I'm probably going to be able to get away with using that Messy and Poloni. That's some good stuff. Okay, I'm going to try that. Short as possible. Also, you're going to want a mast mount preamp. I haven't got that yet. A mast mount preamp is going to be a preamp here that'll give you 20, 30 dB of gain here before it goes over the feed line. Because on the feed line, you might be, you don't want to amplify anything that comes, you don't want to amplify it really at the radio, because you amplify everything that comes off this antenna and through the feed line. You want to, same thing with HDTV antennas, you want to amplify it at the antenna and send it over the coax, not amplify any noise that may be already at the radio before you amplify it. So all you're doing is amplifying noise. So that I'm still working on. A lot of different types of LNAs or low noise amplifiers for the receive, and you got to make sure it handles the frequency. You got to make sure you can transmit through it, or else you got to come up with some way to switch and receive through it and then transmit on a different feed without the LNA, so you don't burn it out, stuff like that. Okay, so where are we at now? So the feed line, and of course you gotta have power, right? So here is my Mirage 430 to 450 D1010 amplifier, 100 watts, 10 watts in, 100 watts out. So I drive it with 5 watts, I get 50 watts out, so I made that contact that night was 50 watts. I can get 100 if I really wanted to. But an amplifier is a must. As I said, this amplifier's got end connectors on the back. Some of them can be keyed, with a keying circuit on the back. There's a lot of UHF amplifiers out there. This may not be the most cleanest signal. Maybe it's all right, but hey, it worked at 50 watts. And I got a neg 24 or neg 25 from him on Q65. We'll talk about that in a minute. Okay, so, and I hope this isn't offending anybody. I'm trying to show you what I did. I know the big guns out there, the guys been doing this for many years, might have something to say, but listen, I'm new to this, and I'm understanding it, so just bear with me. For the new guys who think, this must be very confusing. No, it's really not. You're aiming a signal at the moon to reflect it back to the Earth, and also the trajectory of the moon determines where it's being reflected to. For instance, when the moon was up here, right? Oh, more like that. That's why it went up and came down to the U.S., right? Had the moon, or had I been able to see the moon there at like 2 degrees, man, I can make a serious reflection off the moon to Europe on the other side of the Earth. As you notice, I have power lines and trees here. So being that it is line of sight means it's not like propagation like with HF, where, I'm still working this guy at a parking lot around buildings, but he's in Arizona and I'm in Florida. No. 2 stations must see the moon. So if I see the moon rising halfway up on the horizon at 0.5 degrees, it's setting somewhere on the other side of the planet at 0.5 degrees. That is about the most distant contact you can make, is as it breaches the horizon here and as it's almost gone on the horizon on the other side, somewhere on the other side of the planet. So fun fact is, I think they said 50% of all Earth can see the moon at one time. So you have a chance of seeing the moon with 50% of the planet also being able to see it, if that makes sense. There are stations that I'll never ever be able to work here because when the moon is down there, you know, at negative 40 degrees, I'll never be able to work someone that can see the moon because I can't see it. If I cannot see it, like right now, I could never do Moonbounce today, right now, until about 5:30 tonight when the moon starts rising. However, the moon starts rising there, I need about 15, 16 degrees on the app before I could even see the moon. And at that point, a lot of times, a lot of guys go to bed because they lost the moon. So that's why I'm thinking about taking this down to the beach and going right on the beach and doing it right at 0 degrees and maximizing it. With the 0 degrees also, you do get 6 dB of ground gain. More on that. Look up ground gain EME Moonbounce. That'll tell you. So 6 dB is a big deal. You know, you can add a couple dB with a better coax and reduce dB of loss, and also get 6 dB of free gain just by ground gain by hitting it right at 0 degrees. And it goes from 0 up to like maybe 10 degrees or something where you get ground gain. So that's a must. And also that's the only way I'll work those stations before they go to bed. So, like I said, 1 degree here is 1 degree below horizon somewhere on the other side of the planet, and that means they won't see the moon, but I'll just see it. So, all right, doing this on the phone here, let me show you. This is the site that I go to for scheduling and working with the big guns and the other stations on the other side. Okay, this is the HB9Q logger. Logger.hb9q.ch. All right, HB9Q is a big gun. And this site will allow you to pick your frequency up here and see who's online and coordinate a schedule, because this needs to be scheduled. Very rarely can you have enough equipment to just aim at the moon and just transmit without anybody knowing it, because they have to know where you're transmitting in order to set their software to receive. Now, 50 megahertz, 2 meter, 6 meters, 2 meters, 220, 432, 902, all the way up to 76 gigahertz. Look, there are people. Sorry, the last message was for 47 gigahertz. Oops, he wasn't on 76 gigahertz. But there's a lot of people that are doing this on different frequencies. Now, then you have terrestrial, 5 gigahertz, 10, and 24. Okay. Well, for the sake of this video, 432, and you can see that please refrain from. I don't want people to get on here and say, "Hey, how do I get started? What's the first thing to do?" No, this is a chat for scheduling. These guys are busy. They're not watching this all the time. You don't want to load up. I don't say anything on here unless I'm ready to call CQ and I give him a report. Here's the stations online. Here's the stations. There's a whole list of them. People that were on more than an hour ago. Okay, so HB9Q logger. Again, don't get in here and start asking questions without even a Moonbounce set up and bothering these guys, because this is very highly needed for scheduling. Now, if you get down here, see, this is what happens. This is what I would do too. Okay, we'll talk about the software in a second. CQ 432.065, that's his frequency on a dial. Second, like FT8, you got even, odd, first, and second. He's calling second on odd. You have to make sure, by the way, that your clock is synchronized. I use Dimension 4. If you're familiar with FT8, you'll be familiar with this. My clock is synchronized within 0.4 seconds. All right? Very, very important. Every microsecond matters for your other station to be decoding it, okay? But Q60, he's calling on Q65 mode, so it's Q65-60B, which is 60 seconds, subband B, at 1500 hertz on the waterfall, CFOM, constant frequency of moon. All right, so the software will determine, hey, you got a Doppler shift of 247 hertz, he's got a Doppler shift, whatever, and it'll put you both right around 1500 hertz on the waterfall, so that you're not having to scroll on the dial to try to find them, because sometimes you will not even see or hear it, but Q65 will pop up. I'm going to show you that software here in a second. So anyways, that is what I use, and I have this running so that when I'm calling CQ, I put the message up here, 432.074 first. Here's where I'm at, and I hit send, and that pops up. Now, if there's anybody on like these guys over here they're going to say, okay, and they might switch that frequency, and chances are their Moonbounce are already, their array is already looking at the moon, and they're going to see if they can hear you. And if they can, they'll pop it up here. Hey, this is your message. I'm going to transmit back to you, and vice versa. So Q65 can be used terrestrially like FT8 for different, for 6 meters DX. You can do that. But this was last night, okay? And as I said, I had no luck because I couldn't see the moon, and I'm using the Armstrong method. However, in WSJTX, up here on the mode, you'll see Q65, okay? Q65 is a newer mode that is specifically designed for fast changing Doppler and fading signals, and really designed, or really exclusive for EME Moonbounce they use. I mean, people have used JT65 in the past, but Q65 is the latest and greatest thing. Now, there are, things in here, frequency tolerance. There are max drift rate in units of symbol rate per transmission. There is submodes. And different, if you go to the quick start guide for WSJTX for Q65, it'll tell you all about it. There are certain submodes for different frequencies. If you're at 1296, if you're at 6 meters, if you're at 2 meters, and also the transmit receive, I'm on 60 seconds, which takes a whole 52 seconds to transmit and a whole 52 seconds to receive, and then 8 seconds to decode, or whatever it is. I mean, it'll transmit for the better part of a minute. So you can see right here, there's 50, right about 52, it'll shut off my amp, and at 8 seconds, it'll be decoding, and then it's, switches. So you have to make sure that you are on the same frequency, that you are on the same transmit receive segment, auto sequence on, submode, the right one, and some guys are playing with frequency tolerance and max drift, okay? On the waterfall, as I said here, there's different ways of setting this up. I started playing with setting it up different ways. You can see that it looks a little bit different than JT65 or FT8 rather. All right. One thing that I noticed that is newer or different down here, you see this? It says Q65 sync. Now, the way Q65 works is there is a trace signal, which is like a for timing, for frequency, and your computer locks onto that trace, and it'll kind of look like a line, like one of these. And then in that trace, or around it, there'll be 65 tones. It uses 65 FSK, or frequency shift tones. So you'll see that trace. Your sync will lock onto that trace, and then it'll have the 65 spaced tones. Depending on the submode and all that, it will determine the width and the spacing of those tones. So really easy to know that if your other contact says I'm on 60 seconds at submode B for UHF, whatever, you match that and the computer will do the rest. But if you have a higher signal or a higher station, bigger receive, you can switch to 30 seconds and do the same thing in half the time. Half the time means that it's going to be a shorter duration, closer spacing and yada yada. So the more receive sensitivity that you have, the faster and less spaced you can do, if that makes sense. All right. So that right there will lock on, and you'll see these lines now. I turned it up a little bit, the spectrum here, so you can see it. But you don't want to be, one thing that drives me nuts is how you get this here and these, and I can shift the filter and stuff on the ICOM, and I get lost in that. The SDR that I have, the Rig Expert, man, there's lines everywhere, and there's like no way. I got to shrink it, and this will end up here where I'm at, and I got to compensate. It's a pain in the butt. So I've never really, because I don't use FT8 that much, or WSJTX at all, unless I'm testing antennas. Is the only time I use it, or EME Moonbounce now. This right here will lock on and decode the Q65 potential signal. And when it does that, you may not see anything up here, depending on how you have yours set up. But over here, magically, not there, magically, you'll see something decode. In fact, if you did not see, let me see if I can find a photo. See, this is a screen capture I had the other night. So I didn't see anything on the waterfall, but the program decoded it. I had a neg 24. I gave him a neg 27. There's something about the Q2, Q0, Q3. I forget what that is. He was in Fox November 32. Now you can see the frequency here, 1520 hertz, 1516, 1524. I was off because of the rotation, the wobble, the Doppler and stuff. So that's what, I was on 1500 hertz, but that's what that CFOM will do. Well, it will lock the frequency so that you say 1500. He was telling me, hey, you're up a little bit. You're like 1520s. And that was because I didn't have that set. So even though I did not see anything on that waterfall, that's what was happening. That's how low the signal was and how sensitive Q65 was. Is it pulled out that signal, and I made a QSO with him off the surface of the moon. You may be saying, well, how do you know that that wasn't you? Listen, if my Yagi was facing space at a celestial body 240,000 miles away, there's no way on UHF that I accidentally had sporadic ease from Florida to Massachusetts. You understand? That was directly related to the surface of the moon. In case you're wondering, because I know that comment's coming. Yeah, okay, well, unless it's a DX contact, there's no way. Well, there it is right there. I mean, I called for a while. I called for a long time before I got that, with him waiting to hear me. So it just depends on, the conditions and the moon. I mean, there's sky noise. There is, if you're missing the moon and you're not directly on it, you're listening to some galaxy 4.6 million light years away, or I guess there's how do I put this? There is a phenomenon at certain times, I have to read about this, where the moon is actually in line with the Milky Way, and you're hearing every kind of bit of sky noise from the Milky Way as the moon traverses that path, if that makes sense. I know we're in the Milky Way, but the way that certain areas of the world where it's dark, you can see the band across the sky looking into the Milky Way. Well, that sky noise can also cause a problem on receiving Q65. So just to know, when you're on Q65, you have to know your frequency. Where's that? You have to know your frequency. You have to know odd or even. You have to know a sub mode and stuff like that in your time. So it's a lot of it scheduled, if that makes sense. There's another thing here. This is a window of astronomical data that is in WSJTX. And you can set your Doppler tracking here, and it'll tell you, DX station announces their transmit frequency, which is entered as the scheduled frequency. Correction applied to receive and transmit, so you appear on the DX station's own echo frequency. That requires cat commands, cat control, and such. And it'll tell you your azimuth and elevation, your, self-Doppler correction. So it would be minus 409 hertz. Right now it's negative 65 degrees elevation, so it's way down and nowhere near being able to rise, and scheduled frequency. So this will tell you your stuff too. And if you have a cat-controlled radio, as you make start the contact, it will adjust based on Doppler shift. That's what the CFOM is. Actually, right here, constant frequency on moon. There it is. That's what you want to see. So that says both stations correct for Doppler shift such that they would be heard on the moon at the scheduled frequency. That's what you want. I must have clicked on the other one. So that's WSJTX with the Q65 mode. More about that on the quick start. Okay, and the radio I was using is the ICOM 705, IC705. That's been my go-to for a lot of things because it does have UHF and VHF, upper sideband, lower sideband, AM, CW, and more. So this radio puts out 5 watts, and with the internal battery, or if on my situation, like if you plug in external power to this radio, you'll get 10 watts out. With this W2HVH case, I can flip that on, and now I'm putting out 100%, which is 10 watts. because I'm inputting 13.2 volts to the radio. So if I turn that off, 50%, which is 5 watts. So the ICOM 705 is based on an SDR, so it's got a great, it's got a great receiver on it, and there are other radios that are better. There are other radios you could use. You don't have to have a 705, but you want to make sure that, because you're not even looking at the scope. You want to be on frequency and have the audio and cat commands routed to and from the computer. That's what you need. A very super sensitive receiver for a ham radio would definitely do you better. Every dB counts. This preamp that I have on, that really, really amps up that signal on the 705. Preamp does well. However, I'm amplifying at the radio whatever is coming into that antenna. Power line noise, sky noise, whatever, over the coax, noise coming in over the coax, and here we go. Now I'm going to boost it. That's why a mass mount preamp is better. Can I use a preamp on the radio and a mass mount preamp? I'm not sure. I have to figure that out. Do you need a special case like this for your 705? Absolutely not. Absolutely not. This is just what I've had from Ralph W2HVH, and this is my go-to right here. I plug my USB in here. 1, 2, 3. There's a diplexer inside, or diplexer, where it splits out the VHF, UHF. So there may be a little bit of loss in that. Didn't think about that. I might bypass this and go directly to the side of the radio the next time. I didn't think about that. I might have loss in the unit that's in there. I'm not sure. I haven't looked at the specs or the noise figure or losses or anything on that unit that he puts in there. So one thing I need to know. Should I go right to the side of the radio and avoid it? All that does is break out that same connector on the side of the radio to one port for HF and 6 meters, one port for VHF, UHF. So that's one thing I might bypass because every dB counts. By the way, it pays to have the right ends on your cable, not using adapters that you saw me digging for, just because that increases some loss going from 3 or 4 adapters in a row. One thing I did try for receiving, which sort of worked, the Phobos SDR, I'm not convinced on that thing yet. I really, really need to do a video on this. Not convinced that this is good enough for EME, just because there's a lot of noise and rejections and mirrored images from different bands on UHF on this thing. But if you have a good SDR, there's a lot of them. I've never even played with AirSpy and RigPi or something. I don't know, AirSpy or HackRF, all kinds of stuff. If you have a really good SDR that can receive on 432 or whatever EME band you want to do, you could try receiving before you even try transmitting. And you could also just decode with a schedule and just knowing that, hey, he's transmitting here, he's doing this on this band. I'm going to receive that and pipe the audio from this into your computer. You can't transmit on this, but you could definitely receive and kind of, get your feet wet if you wanted to. But like I said, this one is not really cooperating with me. It lags. I know it's not my computer. I mean, I got a Ryzen 7 on this laptop with a Vega 10 graphics, and it'll choke up, and just choking up 1 second is gonna make a difference in the world decoding a Key 65 signal. So make sure if you have a SDR that you're using a good software, good SDR, and that you're on time and everything is working, no latency between this and the computer and stuff. And you may be able to decode just to try it. If you got an old dish, but you're not set up to transmit, but you can receive, there you go. Give it a shot. Listen. As I said, the angle of the dangle is very important. So you see how high I have to go before the trees? What happens if I go over there? What you'll notice here, that being out front, the angle is way lower when it breaches the trees and the power lines over here. So I can actually get 20 minutes more with a lower elevation being out in my front yard compared to being in the backyard. Last note, and I'll make this quick. So driving my amplifier, I'm using an old Midland 30 amp power supply. Okay, and switching power supply. However, you got to be very careful on what you use because of the noise that can be generated from a power supply. A lot of them are noisy. You know what I'm going to do with this? I'm actually going to run this amplifier from now on with a huge 12-volt battery and just charge it. No noise. I mean, this draws about 21 amps at full tilt. The fan on this, plus the switching circuitry, can definitely cause noise. Every dB matters, remember. So I'm going to be running this on a battery. That way I could, do this in portable situations and stuff. Yes, I'm going to announce this right now. This will be in the back of my truck on a fixed mount. Yes, my diesel with the big 8-foot bed. I'm going to deploy this and drive out to the beach and go to different areas and work at the horizon or just above the horizon. EME Moonbounce, so I can get different aspects instead of waiting for it to come up that high. Yes, I announced that first. You're going to see this in my mobile. Not my normal mobile, but the F-250. I'll have plenty of room to pull over. Have this attached somehow, or a smaller tripod attached in the back of the truck, and be able to Armstrong it in the back of my truck on the beach. That'll be cool. And we got jumpers. Jumpers are a big deal. If you need to go from your amplifier to your radio and stuff like that, using something like this would have more loss than something like this. This is a Messi and Poloni also. I have a link I'll put in the description for Messi and Poloni coax if you're interested. Get a little discount on that from Gigaparts. But these connectors, M&P made in Italy, these connectors are UHF, but I think they have N connectors, I think. But you'd want N connectors. However, the Messi and Poloni jumper here, see, me putting an adapter on here is going to give me a tad bit more loss than I really need. I mean, minute, but every dB matters. So this jumper here, I pulled this out of my jumper box, This is a silver SO239 or PL259 on this side, and then a cheap knockoff one on this side. I might have made this years ago for HF, which will work just fine, HF. This is LMR 400. I used to have some I used to have some RG216 mil-spec C, which was silver-plated center conductor. I had a spool of it, of like 500 feet. And in that process of the move, when I lived in the RV for a little bit before I bought this house, whole roll got scrapped accidentally by somebody doing a demolition job at my grandmother's house. I'll never forgive them or my grandmother for that, but that was a very expensive, huge roll. It might have been more than 500 feet. The big wooden rolls people make tables out of. It was all RG216 mil-spec C. I think it was silver plated too. That would have been great stuff. But running out of time here. The video's getting too long. So one last thing, and then we'll wrap it up. Okay, in the most non-professional amateur way possible, that is what I've learned so far on some things about EME Moonbounce. I know a lot of comments said, thanks, Eric, you gave me the push. Now I got to try it. John Frankie is texting me pictures of this Yagi he has just like this. It's a little different. It's a loop fed here. But it's like 12 elements or something, and UHF. He's like, man, now I'm digging it. Thing's been in his attic for years. And he's sending me pictures. I'm like, yeah, I'll take it. He's like, no. I'm going to dig that out and try this. I want to try it with my 9700. Well, there you go. You don't need an amp. If you have an ICOM 9700, even better. I miss my ICOM 9700 terribly. I've sold it to buy this house, and I had to. I was running out of options. But I'm going to have one of those radios one day, because that'll be ultimate for my EME Moonbounce adventure. So tonight, I'm going to try it again. If you see these clouds, they got to go. Let me put it to you this way. That sky's been blue for 4 months with no rain and just cold front after cold front. I get this thing going, and it's like that train that used to come by. There's nothing but clouds every day now. Sucks. But definitely hope that you guys learned a little bit of something. And hey, comment. Give me an idea on why a regular protractor like this with a string hanging. What do I need to do? I need to add or subtract the distance above ground or something? Because again, see, right? That right there would say, something like 20 degrees or whatever if it was hanging. That ain't 20 degrees. When the moon said 20 degrees, it was way over there. So I got to be doing something wrong there. So the Armstrong method is definitely what I've been using. So I'll wrap it up, guys. Happy Saturday and happy weekend. I'll see you soon.